This is lesson 6.5, Polynomial Equations. Our learning objectives are to use the zero product property, solve quadratic equations by factoring, solve equations with polynomial functions, and solve applications modeled by polynomial equations. So we have spent the previous lessons of chapter 6 helping you with your factoring skills. We get good at factoring expressions so that we can easily solve equations. All right, so what expressions have you learned how to factor? Well, you've learned a variety of factoring skills, and I have a quick little representation of that. So you've learned how to factor binomials with a common factor. So here's an example of me doing that. You've learned how to factor trinomials with an a value equal to 1. Here's an example of me factoring this trinomial into two binomials. You've learned how to factor trinomials with a greatest common factor. Like we looked at trinomials like this, we find a GCF, and then whatever's left, we factor that. You have learned how to factor trinomials with an a value greater than 1. You have learned how to factor by grouping. You have learned how to factor perfect square trinomials. You've learned the difference of squares, factoring, and you've also learned how to factor the sum and difference of cubes. These are just some examples of the types of factoring skills you've learned in the previous 3 lessons before arriving to this lesson today. If you are in need of factoring practice, please go back to those lessons and look those over. Make sure you know what's going on. Okay, with those factoring skills, we can now solve equations, and that's the objective today, is to solve polynomial equations. And to do it, we're going to need to use the zero product property, so let's discuss that. The zero product property says if a times b equals 0, then either a must equal 0, or b must equal 0, or both equal 0. All right? So if I have two factors that are multiplied together and they equal 0, then the first thing is either 0, or the second thing must be 0, or they both must be 0. And the zero product property is very useful in helping me solve equations that have factored pieces. Okay? So here's example 6.44, which says solve 5n minus 2 times 6n minus 1 equals 0. Well, since these two factors multiplied together equal 0, that means this factor can equal 0, or this one can equal 0, or both of them equal 0. And so that's the zero product property. If that's the case, you can write two equations. You can write 5n minus 2 equals 0, and you can write 6n minus 1 equals 0, and you can solve those two equations to solve for n, the variable. Okay, so when I solve for n in both equations, I would add 2, or in this case, add 1 from one side to the other. And then I'd find out that 5n is equal to 2, and I'd also find out 6n is equal to 1. And then we could divide the equation by 5, or in this case by 6, and we would find the solutions for this example, right? The solutions would be that n, the variable, could equal 2/5, and it could equal 1/6. So there are two solutions for what n can equal. Okay, now I'm going to show you a quick trick. Instead of solving these equations explicitly, right, this equation like 5n minus 2 equals 0 or 6n minus 1 equals 0, what we could do to find the solutions for this n is make this value opposite and divide by this. So opposite of negative 2 is positive 2, and then divide by this linear coefficient 5, right? So 2/5 is the answer. And in this case, make this opposite, divide by this, that would be 1/6. So this is how you can solve quadratic equations that have been factored already, right? So we just solved a quadratic equation because we saw the factors were set equal to 0, and then we could find the solutions. And that's awesome. So now you have a skill to be able to solve quadratic equations that are factorable. Now, what is a quadratic equation? An equation of the form ax squared plus bx plus c equals 0 is a quadratic equation, and a, b, and c are real numbers, and a cannot equal 0. Let's explain this a little bit. So it's called a quadratic because the highest power of the variable is 2. When the highest power of the variable, in this case x, is 2, that's called a quadratic equation. Now, this is the quadratic term, this is the linear term, and this is the constant term, and they are set equal to 0. Okay? Now, why can't a equal 0? This a value has to be something other than 0 so that the quadratic term doesn't cancel. Since this is a quadratic, we need this quadratic term to exist. Okay, now how do you solve a quadratic equation by factoring? You can follow this 5-step process. Step 1, write the quadratic equation in standard form. Ax squared plus bx plus c equals 0. We need it to equal 0 so that we can use the zero product property. All right? Now, step 2 is to factor the quadratic expression. So we'll be using any of the factoring skills that you've learned in the previous 3 lessons. Right? So going back, in step 2, you could use any of these factoring skills that are shown here. Great. Step 3, use the zero product property, right? Since the quadratic is set equal to 0. Then step 4, solve the linear equations. And then step 5, check. You can check to know your answer is correct by substituting each of your solutions separately into the original equation to see if the equation is true. Great. So I have a variety of examples. These are examples 6.45 through 6.49, and I'm going to go through them one by one, and we're going to use those factoring skills that we know and go through this 5-step process. So here I go. First, I encounter 2y squared equals 13y plus 45. And the first thing to ask is, well, is it set equal to 0 in standard form? And the answer is no, it's not. So what I'll do is I will subtract 13y from the right-hand side to the left-hand side. And I'll also subtract 45 from the right-hand side to the left-hand side so that I can set this equation equal to 0 because these will cancel. And what I get is, well, 2y squared minus 13y minus 45 equals 0 now. Great, so this quadratic equation has been set equal to 0. Now I'm going to get out my factoring skills. So the goal is to factor this trinomial, and looking at it, it doesn't have a GCF. So I'm going to factor using trial and error, and I will find the factors of the a value. Okay, the factors of 2 are 1 and 2. 2 is prime, so that makes life easy. And then I'm going to find the factors of 45. So I'll list the factors of 45. 1 times 45, 3 times 15, and 5 times 9. I think these are all the factors of 45. So now I'm going to try to factor this trinomial into 2 binomials multiplied together. And this 1 and 2 that I have here, they go with y in the parentheses. So I'm going to have a 1y and a 2y. A lot of times you'll see the bigger value is put in the first binomial, the smaller one in the second binomial, but it really doesn't matter at this point which one you put first. You could have put y and then 2y. I'm going to put the larger one first and the smaller one second, just because that's a typical way to do it. And now I need to figure out how my outer and inner terms of FOILing will multiply together and sum together to make the middle term here negative 13y. So I'm going to need them to make negative 13y. And this takes some trial and error because what goes here and here are one of these sets of factors. And since this is a minus-minus situation, one of my factors will be negative, and that will be likely the larger factor that will be negative. But let's check it out. So I, look at these sets of factors for a minute and I decide, well, this one won't work. And then looking at this next one, it doesn't end up working. And what works is if I have 5 and 9 and I make the 9 negative. And let me show that to you. So if I put the negative 9 in that spot and the positive 5 in this spot, and I multiply the outer and inner terms of FOILing, right? 2y times negative 9 gives me negative 18y. Okay, so this is a negative 18y. And then 5 times y gives me a positive 5y. And if I take those and I sum them together, 5y plus negative 18y, well, that equals negative 13y. That is exactly what I want. Okay, so I have just factored all of this stuff. And why did I factor it? Because now it's really easy to solve. We factor these expressions so that we can solve the resulting equation. So here I have factored this trinomial into this, and it all equals 0. And because it equals 0, I can use the zero product property. And I can say that y, we do that in blue, y must equal, well, make this opposite divide by this, right? Negative 5 halves, okay? Negative 5 halves is the first solution. And then this solution is, well, make this opposite divide by 1. There's a 1 coefficient. So that would be 9 over 1. In other words, 9. Okay, and let me show you why that works. Why does that work? Because that's the same as if I had taken 2y plus 5 and I set it equal to 0, and then y minus 9, if I set that piece equal to 0 as well, and then I solve each one, right? To solve each one, I would subtract 5, or in this case, add 9. And then I'd end up with a resulting piece that says 2y equals negative 5. And then y equals 9. Well, this one's already solved. I got one of my solutions. But this one I'd have to divide by 2 to solve all the way for y. And then we see, wait, well, the solutions are negative 5 halves, yep, and 9. We did it. So you could use the trick of making this opposite dividing by this, making this opposite dividing by 1, right? That's 1. Or you could take each piece, each linear piece, and set it equal to 0 and solve explicitly that way. Whatever you think is going to help you remember the way this works, that's what you should do. Anyways, this was my scratch work. I'm going to get rid of that scratch work and just say, hey, these are my solutions. There we go. Great. So I've just followed this step process, right? I wrote the quadratic equation in standard form. Here it is. It's now in standard form. And it's been set equal to 0. Then I factored the quadratic expression, right, in step 2. Then I used the zero product property to find the solutions, right? Okay, setting each of these equal to 0, I could solve and find these values. You could, of course, check by substituting each of these values into the original equation to see if it's true. I'll leave that for you to accomplish. Let's move on to the next example. It's 169 times q squared equals 49. All right, so I asked myself, is it in standard form? And the answer is no. So I will first subtract 49 from right to left to set this equal to 0. And the result is 169 q squared minus 49 equals 0. And at this point, I look at it and I say, wait, 169 and 49, those are perfect square values. Those are perfect squares. So I could rewrite this as 13q squared minus 7 squared, and that equals 0. And then I would say to myself, that's the difference of squares. Okay, so the difference of squares is a factoring pattern that you must recognize. And so we will factor this into the difference of squares factoring pattern. And we'll say, well, I've got 13q at the beginning of each binomial and 7 at the end of each binomial. And they are separated by addition and subtraction because these binomials are conjugates. Conjugate means you have the same two terms, but opposite sign in the binomials. Now, it doesn't matter where you put the plus and the minus. You could have put the minus here and the plus here. What matters is their opposite signs. And now that you have factored the difference of squares, you can realize that that helps you to solve this equation that's set equal to 0, because now we know that q can equal, well, make this opposite divide by this, and you get negative 7/13. And then make this opposite and divide by this, and you get positive 7/13. And so these are the two solutions to this quadratic equation right here. Those are the two solutions. Okay, so we have solved, and we're done. Great. Well, let's go ahead and look at this next example, which says 3x minus 8 times x minus 1 equals 3x. And you'll say, well, it's already factored, but it's not set equal to 0. And that's a problem because we're going to have to subtract 3x from this right side to this left side, and then combine any like terms, which means we should FOIL these two binomials. Let's FOIL this times this. Remember, FOILing is multiplying the first terms together, outer terms together, inner terms together, and last terms together. So 3x times x gives me 3x squared. And 3x times negative 1, those are the outer terms, gives me negative 3x. And negative 8 times x, inner terms, gives me negative 8x. And negative 8 times negative 1, the last terms, gives me positive 8. And that equals, currently, 3x. Well, I need to subtract 3x from right to left so that I can set the equation equal to 0. And now I'm going to combine any like terms. I've got the quadratic term, which is 3x squared. That's all. It doesn't have any like terms with it. But then I have these three linear terms that can be combined together. Negative 3x minus 8x minus 3x is a negative 14x. And then I have the constant term, positive 8. It's a constant. It doesn't have a variable with it. Okay, so we've gotten to this point. We now have our quadratic, and it's an equation in standard form because it's been set equal to 0. Since it's set equal to 0, we can factor this if possible and then use the zero product property. Great. So you're asking, how do you factor this? Well, it doesn't have a GCF, so we immediately find the factors of the a value, right? So the a value is 3. I find its factors are 1 and 3. It's prime. And then I look at the c value, the constant, and I say, what are its factors? Well, 8 is 1 and 8, but it's also 2 and 4. Great. So these are the factors of the constant, the c value. All right, so now I'm going to do trial and error to see, can I combine these factors with one of these sets of factors to make negative 14x, right, for the outer and inner terms of FOILing. And so I will show you how to do that. I create two binomials, and in those binomials, I put a 3x and a 1x. Why did I do that? Well, these are the values that go with x in the binomials, 1x and 3x. Okay, and then what goes here and here is one of these sets of factors, and I need to play with minuses and pluses because I see this is a minus plus situation. Both of my factors will be negative, and I have to make negative 14 with the outer and inner terms of FOILing, right? So whoosh, whoosh, I need to think about that. And so I think for a second, and I say, well, what if I make the 2 and the 4 both negative? Yeah. And then I'm going to just get rid of that because that won't work. And so I'm going to put a negative 2 and a negative 4 in these spots, and it's very important what order I put them in. In fact, I'm going to decide to put the negative 4 here and the negative 2 here, and maybe you'll see why when I multiply the outer and inner terms together. Negative 2 times x is negative 2x. And 3x times negative 4 is negative 12x. And if I sum negative 2x plus negative 12x, it gives me negative 14x, which is exactly what the middle term is right here. And this is why I've made all the decisions that I've made. Okay, and so there I have now factored. Okay, I'm going to erase some of this side work that I just did. to get the results that I have. Okay, but now that I'm here and I have factored, well, I can now solve this equation because it's set equal to 0. And so I know that the solutions for the x values, this x value and this x value are, well, make this opposite, divide by this, so it's 2/3. 2/3. And make this opposite, divide by this, which is, it's an invisible 1. That's a 1x. So positive 4 over 1 is just positive 4. And these are my solutions. And I have solved this equation, this quadratic equation, using my factoring skills. And you are starting to do the same. Okay, now, once again, if you ever wanted to explicitly find the solutions, you would set each piece equal to 0. So the 3x minus 2, set it equal to 0. And the x minus 4, set it equal to 0. And then solve those for x, right? So that means 3x equals 2, or x equals 4. And then x equals 2/3, because we're dividing by 3, right? So in the end, I add 2, and then I divide by 3. And so that's why I can say make this opposite, divide by this. Okay? All right, so this is showing you explicitly how I can solve these two equations set equal to 0 to find my two solutions for x. We have now solved for x. All right, let's go ahead and move on to the next equation. Here we go. This next equation says 3x squared equals 12x plus 63. And the first thing I notice is it's not in standard form, and so I will subtract, this 12x from right to left, and I will subtract this 63 from right to left, so that I can have all of my terms on one side, the 3x squared. Let me write 3x squared minus 12x minus 63, and it's now set equal to 0 because I want to use the zero product property. That's why I'm setting it equal to 0. And now this trinomial, I'm going to check to see if I can factor it. And in fact, it has a GCF. You should always check for greatest common factors. The GCF is 3 in this case. And so I end up with x squared minus 4x minus 21 in parentheses. And now this is a trinomial that's easy to factor, right? Just think of the factors of 21. Which factors of 21 can also sum to make -4? That's what you're thinking in your brain. And so I'm going to create two binomials from this trinomial. And I'm going to put x at the start of each one. And now I'm going to pick, well, what are the factors of 21? Let's write them on the side. 1 and 21 and 3 and 7. But I need them to make -4, so I play with the signs a little bit. And I find out, wait, this is 3 and -7 that go here. So +3, -7, like that. Great. And so this is all set equal to 0. Okay. And now I need to solve, right? I've completed the factoring. The last bit is to solve for x here and here. Now this 3 that I factored out in the beginning as a GCF, it does not have any weight in my decisions for what the solutions are. So you can ignore this value out front. It does not impact our solutions. But we can think critically and say, well, something plus 3 equals 0. And that x value is -3. -3 plus 3 gives me 0. So I know that's one of the solutions. And then that value, that x value, that's 7, because 7 minus 7 equals 0. So this is the reasoning for why I'm picking these solutions. Okay? Great. So we have now solved this quadratic equation, and the two solutions are -3 and +7. It's typical to separate your two solutions with a comma, right? That's what we've been doing throughout this whole thing, separating our solutions with a comma. Okay, let's move on to our fifth equation here. 9m cubed plus 100m equals 60m squared. And you're right. I should subtract 60m squared from the right side to the left side so that I can set this equation equal to 0. And I'm going to write the terms with the highest power of the variable to the lowest power of the variable in that order to put it in standard form. Okay, so there we go. We've rearranged the equation so that it looks like this. Now I'm going to look for a GCF. And I see a GCF. The GCF is m. And so I'm left with 9m squared minus 60m plus 100. Now there's a factoring pattern that you've learned about that this looks like. This is a perfect square trinomial. Okay, so to find a perfect square trinomial, we say, is this and this a perfect square? Like the starting term and the last term, are they perfect squares? And the answer to this is yes. Like 9m squared, its perfect square is 3m, right? Because when you square 3m, you get 9m squared. And then 100, well, that's just 10, right? Squared. So 100 is the perfect square of 10. And this middle term, we check to see, is it 2 times the first term times the last term for the base, right? So I take 2, I multiply it by this, and I multiply it by this, and I see, yes, well, 2 times 10 is 20, and 20 times 3m is 60m. So this checks out. This, I have just proven to you that this is a perfect square trinomial right here, this thing right here. Perfect square trinomial. And so why does that help me to know that? Because now it's easy to factor. Okay, so what I'm going to do is I'm going to take that m, the GCF that I pulled out already, and then I'm going to take 3m and 10 and put them in a binomial, right? The 3m and the 10, they go in the binomial. And I see a minus sign right there, and that's why I'm going to put a minus sign between the two terms in the binomial. And then I'm going to raise that binomial to the second power, meaning I'm going to multiply it by itself. Okay, and so this is the factored version, right? This is the factored version of that. Now, some students ask, could I factor the perfect square trinomial that I see here? Could I factor it just with my normal factoring skills? And the answer is yes, right? You don't have to recognize the pattern to factor it, but if you do recognize the pattern, it's going to be very useful for your near future. Great. And now that we have factored completely, it's easy to find the solutions for m. So m, if you have an m that gets factored out just like this all by itself, then that solution is 0. That's one of the solutions to the equation, okay? So this m all by itself, its solution is 0. And then this m right here, its solution is make this opposite, divide by this. Well, that's 10/3. Okay? And so these are the two solutions that we have for this equation. We have solved now 5 different equations using our factoring skills that we've gained over the past 3 lessons. Let's move forward. So let's talk about solving equations with polynomial functions because that's our next objective today. And I'm going to give you a quick definition. The 0 of a function. For any function f, if f of x equals 0, then x is a 0 of the function. So meaning, if you input an x value into the function and its output is 0, we call that x value a 0 of the function. It's also called an x-intercept, right? Because an x-intercept is the location on the x-axis, and the x-axis is when the y value is 0, okay? So the 0 of a function is also called an x-intercept. Great. So now that we have this definition, 0 of a function, we're going to see them talk about it in some examples. Like this example asks for the zeros of the function. And so I will show you how to handle that. Let's talk about example 6.50. It says for f of x equals x squared plus 2x minus 2, find x when f of x equals 6. Well, my brain tells me, well, they just defined a function, f of x equals this stuff, but they also said that f of x equals this stuff. And so if f of x equals these two things, that means these two things equal each other because they both equal f of x. And so you would want to write these two things set equal to each other, right? X squared plus 2x minus 2 equals 6 because they both equal f of x. Now that I have set these equal to each other, I can solve this equation using my skills. So let's set the equation equal to 0, right? We have to do that. And so rewriting it, I have x squared plus 2x minus 8 equals 0. All right? So I just subtracted 6 from this side to this side. And negative 2 minus 6 is negative 8. And now this side of the equal sign is now 0. These two cancel. Now I'm going to factor. And I find out, well, this is an easy factoring. So I put x at the start of each binomial. And I think of two numbers that multiply to make 8, but sum to make 2, right? Positive 2. And I think for a second, and I find out, wait, that would be positive 4 and negative 2 that go there and there. Okay, and so now I have found out that x can equal, well, this x equals negative 4 because negative 4 plus 4 equals 0, right? So negative 4. And then this x is positive 2 because 2 minus 2 equals 0. Great. I have just found the x values for when f of x equals 6. These are the two x values. Now, part B says find 2 points that lie on the graph of the function. Well, we can find 2 points by taking the x values and inputting them into the function, evaluating the function to spit out y values. So I'll do that for you. I'm going to take the original function and I'm going to input 2 and negative 4 into the function, right? And so I get negative 4 squared plus 2 times negative 4 minus 2. And then I get 2 squared plus 2x, or 2 times 2 minus 2. What have I just done? I've taken this defined function right here, right? And I've input negative 4 for x there and there. Here's where I'm doing it, see? And then I'm taking the x value of 2, and I'm replacing these x's with 2 right there and there. Okay, and now I'm going to finish evaluating the function. Like negative 4 squared is 16, and then 16 minus 8 is 8, and 8 minus 2 is 6. So the output is 6. And then I do it again. 2 squared is 4 plus, well, another 4. So I get 4 plus 4, 8, minus 2, 6. So when I evaluate the function at these two x values, the y value is 6. Meaning, I've got an xy coordinate of negative 4 comma 6 for the first point and 2 comma 6 for the second point. Well, this is kind of interesting to me because they said for this piece, f of x equals 6. Look, these are the x values that cause a y value of 6 to happen. And literally, I plug these into the function, and the output y value of 6 happens. So this really makes sense that these are the 2 points that lie on the graph of the function. Great. Let's move on to example 6.51. For f of x equals 3x squared plus 10x minus 8, find the zeros of the function. Now, to find the zeros of the function, we take 3x squared plus 10x minus 8, and we set it equal to 0, right? The function y value is 0. Okay, now we can practice factoring. So I'll factor this trinomial. I look for a GCF and I don't see a GCF, so I find the factors of the A value right there, and I'm going to find the factors of the C value, and I'll write them here. And I need to figure out how those factors here on the left and the right sides, right? This factor combines with one of these sets of factors to make positive 10x. And so I'll start, playing with things, little trial and error here. And I'm going to put a 1x and a 3x. And I see that this is a plus minus situation, so one of my factors will be negative. And I play with it for a second, and then I see, oh yes, this is going to work. 2 and negative 4. And the 1 and the 8 will not work. And let me show you why the 2 and the negative 4 work. Because if I put, is it 2 and negative 4? No, I think it's going to be negative 2 and positive 4. Let me try that out instead. Okay, so looking at this for a second, if I put 4 here and negative 2 here, right? Then I play with the outer and inner terms of foiling for a second. And I multiply the outer terms together. 3x times 4 is 12x. And then the inner terms, negative 2 times x is negative 2x. And if I sum them together, negative 2x plus 12x gives me 10x, which is exactly this middle piece right here, positive 10x. So this shows you, why I'm making the decision that I'm making when I'm factoring. Now I'm going to erase some of the work that I just did so that I can work on the rest of this stuff. Because now that I have factored this trinomial, and it's set equal to 0, I can quickly find the solutions, right? So what are the solutions? Well, make this opposite, divide by this, so it's 2/3. 2/3. And the second solution is, well, negative 4, because negative 4 plus 4 equals 0. So there we go, negative 4. Okay, so I have found the zeros of the function. Right? These are the x values that cause the y value to be 0. Now, we said that zeros of the function are also called x-intercepts. So any x-intercepts of the graph of the function? Well, yes, these are two x-intercepts. We're going to write them as ordered pairs, like 2/3 comma 0. That's the first x-intercept location on a graph, right? And then negative 4 comma 0. That is the second x-intercept location on the graph. There are two x-intercepts on the graph of this function. Now, y-intercepts. Are there any y-intercepts on the graph of this function? Well, you may recall from the past, to find a y-intercept, we let x equal 0 and solve for y. Okay, so let's do that with the function, right? So we could say y, or f of x is y, and it equals 3 times 0 squared plus 10 times 0 minus 8. Well, what just happened? What is this stuff? Well, that's the original function, right? F of x equals 3x squared plus 10x minus 8. But we're going to let x equal 0. So these x's, they're going to become 0. And remember, f of x is just y. And now if we solve for y, it's very easy because this stuff that is multiplying 0 cancels. And so we find out that y equals negative 8. That is the location of the y-intercept. And if I write that as an ordered pair in space, right, that's 0 comma negative 8. It has an x value of 0 and a y value of negative 8. So there we go. We have just found the zeros of the function by setting f of x equal to 0 and then using our factoring skills to solve for x. We have found x-intercepts because these zeros that we found are literally the x-intercepts. And we found the y-intercept by setting x equal to 0 and solving for y. And there, you've seen it. All right. So how are we going to wrap up this lesson? Well, we're going to wrap it up by solving applications that are modeled by polynomial equations. We're going to start to see some real world scenarios, and we're going to use our skills to solve some of these quadratic equations by factoring. So here's a quick step process for how to use a problem solving strategy in solving word problems. And this is the same strategy we discussed over many lessons in the past. So anytime we have word problems, we'll follow this general step process. Step 1, read the problem and make sure all the words and ideas are understood. Step 2, identify what we are looking for. Step 3, name what we are looking for and choose a variable to represent that quantity. Step 4, translate the English into an algebraic equation. Step 5, solve that equation using your appropriate algebra techniques. Step 6, check the answer in the problem and make sure it makes sense. Step 7, answer the question with a complete sentence. Great. So let's look at example 6.52, which says the product of two consecutive odd integers is 323. Find the integers. Now, when I read this statement, my brain wants to turn this into an algebraic expression. Really quick, two consecutive odd integers, we don't know what they are, but we know that odd integers that are consecutive are two apart from each other, right? Like, let me just write like a list of odd numbers, 1, 3, 5, 7, etc., right? How far apart are 1 and 3 from each other? They're 2 apart. You're adding 2 every time to get from one odd integer to the next consecutive odd integer. Now, if I'm using algebra for this, and I don't know what the first odd integer is, I just call it x. But I want to take the product of these two consecutive odd integers, so I'm going to multiply that x with 2 more than what it is, because I know that's the next consecutive odd integer. Okay, it's 2 more than the one that I started with. So I've written x times x plus 2 as the two odd consecutive integers, and I'm multiplying them, right? This is x times x plus 2. And it is equal to 323. So I write equal sign 323. And there we go. I have set up an algebraic equation, and I can use this equation to solve for x. But before I do that, I'm going to jump in and set this equal to 0, right? Because I want to like try using my factoring skills, stuff like that. And so maybe I distribute this stuff and I get x squared plus 2x. And then also, I need to subtract 323 from right to left. And so that now makes sense why I would put a minus 323 next and set that equal to 0. Okay? So there we go. We have set this up. And we have x squared plus 2x minus 323 equals 0. The next objective would be to try to factor this and see if I could take that approach. All right, so that's going to be my attempt. I'm going to try to factor this now. And, you know, if it factors out well, then I should be able to create two binomials like that. And then I ask myself, well, what would this factor to? What are the factors of 323? That's a big number, first of all. And so thinking about it for just a second, I end up, like trying to break 323 into its pieces. And I realize that 323, one of its sets of factors is 17 and 19. Now, if you struggle to find some of these factors, that's okay. You can hop on your calculator and just start dividing out numbers, right? 323 divided by 2. Nope, doesn't work. 323 divided by 3. Nope, doesn't work. 323 divided by 4. Nope, doesn't work. And you would keep going, but at some point you would reach these numbers 17 and 19. And so you could say, and that's great because they're 2 apart from each other. These factors are 2 away from each other, which is the middle value, positive 2x. Okay, so I end up writing x, well, plus 19. and x minus 17. Why does the 17 have to be negative? Because they have to sum to make positive 2. Okay, there we go. And now I would conclude that my two solutions, right, for x, well, x could be negative 19 or it could be positive 17, right? Based on our solving skills. This x could be negative 19 and this x could be positive 17. Well, at this point, I'd have to make a decision that, wait a second, I don't think it's going to be negative 19. I think it's going to be 17 for that first odd integer. And then if I increase that integer, right, 17, if I increase it by 2, adding 2, I get actually positive 19. And so these are my two consecutive integers, odd integers that I had to find. Okay, so there you go. Let's go ahead and move on to a second real-world example. And it says a rectangular bedroom has an area of 117 feet. The length of the bedroom is 4 feet more than the width. Find the length and the width of the bedroom. Whenever we have a geometry problem that talks about like a rectangle or a triangle, I like to create a diagram really fast. So here's a diagram of a rectangle. And that rectangle has an area of 117 square feet, right? So I'm going to write that here in the middle. Now the length of the bedroom is 4 more than the width. Okay, so if I took the length and the width like this, I could rewrite the length in comparison with the width. It's 4 feet more than the width. So it's W plus 4. Okay, so we can just write the length in terms of the width, and then it becomes nice and simple. Now, little reminder for you from the past. The length times the width equals the area, right? Area is length times width for a rectangle, and you need to know this formula just from our past discussions and maybe discussions you had in an earlier math class, right? So I know that the area is 117, so I can replace this A in the formula with 117, and it equals the length, which is W plus 4, and that's multiplied with the width, which we're just calling W. Okay, so I just replaced A with 117 and L with W plus 4 because that was the information given to me in the problem. But this is a quadratic equation, and perhaps I can solve it. Yeah? So let's go ahead and solve this quadratic equation by distributing this W into both these terms, right? And W times W would give me W squared. And then I have a plus 4W. And then I want to subtract 117 over here, right? So that I set the equation equal to 0. So I have a minus 117. And so that's all equal to 0. Now, it doesn't matter what side you put the 0 on, right? You could say equals 0 on the right-hand side, which, you guys are used to. So it's kind of nice to do that. Great, so we got to this point. We have a quadratic, W squared plus 4W minus 117, it equals 0. The question is, can we factor this? And are there values, right? What are the factors of 117? What things factor to 117? Thinking about that, I have 1 and 117. Well, that's an option. But there's also negative 13 and 9. Okay, so let's think about 9 and 13 as factors of 117. So, I just jumped on my calculator and I started dividing 117 by things, and dividing it by 9 gave me 13, which that came out really clean and nice. Now I need the 9 to be negative right here. Why do I need it to be negative? Because I need them to sum, right? Negative 9 plus 13 need to sum to positive 4. That's what'll do the trick. And so I have W minus 9 times W plus 13 that go in the binomials. I have now factored this trinomial. And the last thing to do is to say what W equals. What does the width equal? Well, this width, right, that W could equal 9. 9 minus 9 equals 0. So 9 is one of my solutions for the width. And then, well, that W is negative 13 because negative 13 plus 13 is 0. And so that's why I'm making the decision I'm making. And at this point, one of these values doesn't work because widths can't be negative. Okay, width is it's a dimension of space. Like when you measure something, you can't have a negative length. So you'll always get rid of the negative answer, okay? And you'll say that the width must be 9. The width must be 9. But then we say, well, we need to find the length and the width of the bedroom. But since we found that the width is 9, we know the length is the width plus 4. So I just need to take 9 plus 4, and we'll see something interesting. 9 plus 4, that gives me 13. Okay, so that's what the length is. And it just so happens to be that dimension that we crossed out here because it was negative. Okay, so if you made this positive, that would be what the length is. But we just went through the process of solving for the width and the length of this rectangle. Let's move on to 6.54. A boat's sail is in the shape of a right triangle. The hypotenuse will be 17 feet long. The length of one side will be 7 feet less than the length of the other side. Find the lengths of the sides of the sail. So when they tell me I'm dealing with a right triangle for the boat's sail, I immediately create a diagram. Okay, so creating that right triangle there. And I'm going to label the diagram with things that I know, like the hypotenuse will be 17 feet long. The hypotenuse is the longest side of the right triangle. So there's the 17 feet. The length of one side will be 7 feet less than the length of the other side. So if I call one side length x, then the other one will be 7 feet less than x, right? So I would call this one x minus 7. Okay, so I've now created, representations of what each side length is. And I think for a second, do I know any formulas for a right triangle? And the answer is yes, the Pythagorean theorem. The Pythagorean theorem says the two short sides summed together squared, right, equals the hypotenuse squared. It's stated as a squared plus b squared equals c squared, where a and b are the sides of the short legs, and c is the hypotenuse length. Well, that means that I can write this as, well, x squared plus x minus 7 squared equals 17 squared. So I'm applying these values in the Pythagorean theorem. Okay, now that I've input those into the Pythagorean theorem, I can now solve this equation for x. To do it, it's going to take a little bit of thought. So here we go. The first thing that I would likely do is I would expand this x minus 7 squared. Remember, the definition of squaring something is multiplying that thing by itself. So it's x minus 7 times x minus 7. To help you, I'm going to actually write that. X minus 7 times x minus 7. That's what x minus 7 squared is. There you go. And now we're going to FOIL it. We're going to multiply it all together. So I have x squared plus x squared minus 7x minus 7x plus 49. And that equals 17 squared. Right? 17 squared. Well, that's 289. So I'm going to write 17 squared is 289 just to start to simplify things a little further. And then I get to this point. By the way, what did I just do here? I just multiplied x times x to get x squared. X times negative 7 gives me negative 7x. Negative 7 times x gives me another negative 7x. And negative 7 times negative 7 gives me a positive 49. That's how I got this stuff. Great. Now I'm going to subtract 289 from the right to the left to set this thing equal to 0. Because we want to try to solve with our factoring skills. And now let's write the result as cleanly as we can. So I notice I've got x squared plus x squared, which is 2x squareds, right? I'm simplifying everything here. So I've got 2x squared. Okay, and then I have negative 7x minus 7x, which are like terms. That gives me negative 14x. And then 49 minus 289, that gives me negative 240. And that's now equal to 0. All right, so we've now gotten this thing so that it equals 0. And then I think, is there a GCF? Yes, there is a GCF. The GCF is 2, so I can factor a 2 out of this, and I get x squared minus 7x minus 120 when I factor 2 out of every term. Okay, now I'm going to take this trinomial and I'm going to factor it. And I think for a moment, and I say, well, that's going to be x. Well, what two numbers multiply to make 120, but sum to make negative 7? Oh, I got it. It's going to be x plus 12 times x minus 5. Right? So, if I take 12 and negative 5, they sum to make negative 7. And 12 times negative 5 is negative 120. So there we go. And we are pretty much done. We just need to write what the solutions for x are. But now that it's factored, it's easy. X is negative 12, and x is 5. Right? X is negative 12, because negative 12 plus 12 is 0, and x is 5. 5 minus 5 is 0. And then I think, wait, x represents a length. X is a length. It can't be negative. Lengths can't be negative. And so I get rid of the negative 12 option, and I now know that x equals 5. Right? So this length right here, this length x is 5. Okay? And then, well, what would this last length be? I see where I went wrong. I've done something incorrect up to this point. I'm going to fix it right now. The two numbers that will actually multiply to 120 but sum to negative 7 are negative 15 and 8. Negative 15 and 8. I chose incorrectly right there. Okay, negative 15 times 8, that's negative 120, and negative 15 plus 8 gives me negative 7. That fixes my issue that I just had. Okay, so now x can equal positive 15 or negative 8, right? So this x is positive 15 because 15 minus 15 is 0, and this x is negative 8 because negative 8 plus 8 is 0. And now I can cross out the negative option, and I can say that x equals 15. And then I can go over here and I can say 15 minus 7 is this value, right? Which 15 minus 7 gives me 8. These are my solutions for the lengths of this right triangle. And to finish off our lesson, we have one last example. Dennis is going to throw his rubber band ball upward from the top of a campus building. When he throws the rubber band ball from 80 feet above the ground, the function h of t equals negative 16t squared plus 64t plus 80 models the height h of the ball above the ground as a function of time t. Find a, the zeros of this function, which tell us when the ball hits the ground. Great. Well, they just said find the zeros of the function. So we're going to take this function and replace h of t with 0. That's the height. The height is 0. So I'm going to write negative 16 t squared plus 64t plus 80 equals 0. We're finding the zeros of the function. Now I look at this function and I say, well, can I factor it? And it just so happens there's a GCF. The GCF is negative 16. And so what's left is t squared minus 4t minus 5. Okay, so we just factored out the GCF. And now we ask, is this piece factorable? Can I factor this trinomial? And it looks like I can. So I'll go ahead and do that. I have negative 16 multiplied with t minus 5 times a t plus 1. All right? Why am I saying this? Negative 5 times positive 1 is negative 5, and negative 5 plus 1 is negative 4. So I've been able to make my choice in the factoring. And so now that I have this, it's set equal to 0, so I can say, wait, this t is 5 and this t is negative 1. Right? So my values of time are negative 1 and 5. Okay? And then I think for a second and I say, wait, one of these doesn't work because time can't be negative after he throws the ball. He can't throw a ball and it land backwards in time. So there's only one real world answer to this, okay? And that's t equals 5. And what are we talking about? Well, that's seconds, right? T equals 5 seconds. That's the amount of time it takes for the ball to hit the ground from 80 feet above the ground. Now part B. When will the ball be 80 feet above the ground? Okay, so we can write the equation set equal to 80. So we're going to take h of t and make it 80, right? And so I would have negative 16 t squared plus 64t plus 80 equals 80. Because we want to find the time when the ball is 80 feet above the ground instead of 0 feet above the ground. And going through this process, well, we need to set the equation equal to 0, right? To use the zero product property if that's possible. And so I end up with negative 16 t squared plus 64 t. And then this positive 80 and negative 80 cancel each other in both cases, so this all equals 0. And then I try to factor it, and I say, well, yeah, I can factor the GCF of negative 16. So I'll do that right here. Negative 16 is the GCF, and I'm left with t squared plus 4t, and that equals 0. And then I think, wait, that wasn't quite the GCF because I could also factor out a t, and that will make my life even easier. So going back just a little bit, I decide, well, the GCF isn't just 16, it's 16t. And so what's left inside is just t plus 4, and that equals 0. Now, the solutions for time in this equation are, well, that t is 0. Any variable that you've been able to factor out by itself, that's 0. And then this one right here, this t, is negative 4. Negative 4 plus 4 is 0. So there we have it. Okay. We have one little issue, and that's that this should be a minus sign, which makes this a plus. Okay, that's fixed. Why is that the case? Because I factored the negative out here, right? This negative got factored out, and so this plus became a minus. All right, so it seems that the ball will be 80 feet above the ground at 0 seconds, the moment that Dennis goes to throw the rubber band ball, because he's at a height of 80 feet, and then it reaches that height of 80 feet again at 4 seconds. Okay? Now let's go ahead and finish strong, and we have the height of the ball at t equals 2 seconds. Well, they just told me t is 2 seconds, so I'm just going to input 2 into the function. So I'm going to evaluate the function at 2. H of 2 equals negative 16 times 2 squared plus 64 times 2 plus 80. And that gives me, well, negative 64 plus 128 plus 80, which gives me a height of 144 feet. Great. So we've just evaluated the function at a time of 2 seconds. So after 2 seconds, the height of the ball will be 144 feet. And this has been a big lesson. Thank you very much. I hope you have a wonderful day.